Hi, this is April Schumer, and I am doing my final presentation on the Oregon Trail in CIT260. And here we go. First, I'm going to start with the static variable. So if you look right here in the private static, so here I am starting off the instant static variable that belongs to the class definition. Anything that has access to this definition has potential to be able to share, because static is it's a good sharer. We use static attributes that are attached to the Oregon Trail. Next, here's an example of a static method. I'm using the wagon class to create a single static container that the player will use and access in their game. We are passing a wagon into, we're passing in a wagon that already has containers inside of it. So we use this method to perform some extra logic and to get the containers we want back out. We're using the public static method and the container as our return type. The player will be able to use and access the container in the game. It is a shared function. Next, I'm going to demonstrate a non-static in the wagon class in the model layer. And right here we have, we're each basically assigned one wagon on our trail, and we can have different variables inside the wagon. So we can have, different lengths or widths or heights. So we use the static method that returns a container. So we have one wagon with different variables that we can put in it. So the variables can be different and change, but the non-static are instances of the same, so they're directly related to each other. And let's see. Non-static variables are independent of the class definition. They belong to a concrete class. I chose to use for my non-static function in the view class, in the main menu view class, the get help. So basically we have to call it, and then this is where it displays its method. So we're creating an instance of a view class in order to call and display its method, because its method is non-static. This is also a great place to show you an array. So here we have an array right there. Because the number of containers was known at compile time. So here we have, so it's known up front, and it was known before compile time, and it cannot change. It has a fixed amount of containers. In our game, you could have a maximum of 5 containers per wagon. So because we knew the information up front, it's a perfect example, up front and before compile time, it's a perfect example of an array. Okay, an array list is what I'm going to show you next. And an array list is different from an array. It does build off of an array. However, we use an array list when we know that when items are subject to change, right? So in the game, when the player moves from point to point, that we know that it is going to change up front. So we want to make sure we used an array list, which we did here. And basically we said, if the player wants to, he can basically move up to 5 points, 1 to 5. So if he tries to enter a destination that's greater than 5, he will be told that he can't travel that distance. So anyway, he has to stay within the point range. And this is a perfect example of how we used an array list to, to be able to demonstrate this in our game. Now we're going to come over to the container weight, and I am going to show you, I will try to not butcher it too badly. I'm going to show you the basic for statement. Okay, right here. So the for begins to run the loop. It states that the integer is equal to 0. And if that, of course, is true, it moves to the next section, which is the integer is less than max. And if you look right above it, you can see the definition for an integer or max equals OregonTrail dot get current game dot get wagon dot max number containers. So as I told you previously, we're limited to 5 containers per wagon in our game. So basically, the for loop is going to go through each one, and it will accept up to this much, contents, and then it will output. When it's completed running through the for loop, it will output and give us a total weight. Okay, I've come over to the inventory type, and I'm going to show you an enum. Enums are used for constant values with fixed data structures that is determined upfront or beforehand. So if you recall, an array is used for one of those that same purpose. So in our enum, we have the inventory, and basically we said, here's the cost and here's the weight. So we knew those were, what we controlled and used with our enum. Let's see. So we know exactly what an enum represents. I've used, it has fixed size data structures. The contents in the array can change. So you can pick any one of the items. The size cannot change, however. So once it compiles, it's too late. You cannot change it. So we have examples here of using, let's see, public or private and public final. By making this public final, the functions are constant and can be accessed throughout without getting any getters. Function, which we have the contents inside. It's concrete instances of the inventory to give each actor values of things beforehand. So values are supported by constants, or supposed to be constants. And again, I use the inventory type enums because we know and have exact expectations of how each item will be presented throughout the game. In my wagon control class, I am going to show you where I'm throwing an exception right here. And, after I throw it, it is going to propagate until a try-catch block catches it or handles it over in the view layer. Throwing it in one place and catching it in another is called exception propagation. Let's go find it in the view layer. And here in my container weight view, we have our try catch block right here. So this is where, so it's been propagating, you know, this at this time, and now it's going to be caught right here. Line 95, I should say the try catch block is what it's called. 95 to line 111. So this is where I have caught my exception. And I just wanted to show you, again, this is also where we would be printing our report. So I'm going to go from here, and I am going to go just to show you my view interface in order, you know, to be able to display, get input, and my do action. That's where those are located. I also wanted to show you should show you my input first. My input stream here, and this is where we have our buffer reader coming in. And then I want to show you my output. That's where things are going to be pushed out. And I want to show you, this is my print writer, of course. And then I want to show you our color that we had added throughout several areas of the game. So then, let's see, this is where we use the size to calculate the dimensions and the volume, and control our weight, and use public static containers to sort. Another array list. Now I'm going to play the game for a few minutes. Okay, so I'm going to come over here and play the game. Okay, welcome. And there's the color. We are going to start a new game. Going to be a banker. Congratulations, you're a banker. And look at Jeff, Bobby, and Brittany. Okay, so from here we're going to start the trail, and we will move player. This is where I'm putting in coordinates. Cannot go more than 5. Okay. So we go 5 to 9. And I'm going to list the locations. And in this case, I'm going to exit. I wanted to show you here's the list of our locations. Now I'm going to try to print map report. And here I am going to calculate the container weight. And I want to display containers. These are the containers and the report. Thank you for joining.